Okay, let's pick up where we left off. We're going to be on example 3. This is section 1.8. The last example we did was with James driving his car a certain distance. So, for example 3, we're looking at geometry now. The problem says, find the measure of the third angle of a triangle in its simplest form if one angle has a measure k degrees and the measure of the second angle is 15 less than half the measure of the first. All right. It seems like it might be complex at first. What we might want to do is draw a diagram. So let's begin by looking at a triangle. In this triangle, we know that one angle is k. So we'll start with a k. We know that the other angle is 15 less than half the measure of the first. So I know already that this angle down here, we'll identify this one, will be 15 less, which means minus 15, less than half of the first angle. Half of the first angle. Let's put parentheses and a degree symbol so units are correct. So we've got two angles in this triangle, and it asks us to find the measure of the third angle. Now, you have to ask yourself, remember from geometry here, the sum of three angles of a triangle, the interior angles, must always be 180. So with that said, we can call this angle x. We can say that x plus k plus parentheses 1/2 k minus 15 equals 180. And notice I've dropped all the degree signs. I've dropped all the degree signs here. Now if I do that, I should really put a degree symbol next to my x. All right, at this point in time, let's take a look. And it says, determine the third angle in simplest form. And clearly it's going to be in terms of x, in terms of k here, because we don't have numerical values. So I want to solve for my unknown variable x. Now, before we begin, we might want to start by taking a look at combining our like terms. Combining our like terms. So I'm going to see here that I can write the next line as x plus, and remember, these parentheses here, I really don't need them, because we're adding two things together. So you can kind of drop these in your mind. And then combine the k and a half a k. And a k plus a half a k is going to be 3/2 of k. Minus 15 equal 180. How do I know it's 3/2? Because this is really 2/2 in the front. Okay, there's a 1 in front, which is 2/2. So now at this point, all we're doing is solving for x. So we have x is equal to, let's move this 15 over. We're going to have a 195 here. Then we're going to take the 3/2 k and subtract 3/2 k from both sides. So let's put a minus 3/2 k, and that is our answer for x. It looks kind of odd because there's no number there, obviously. So you're not used to this maybe, but again, we're solving for x in terms of the other variable k. In terms of the other variable k. All right, let's take a look at number 4 now. Number 4. In terms of m, what is the sum of 5 consecutive even integers if m is the fourth integer, So first of all, let's give an example of consecutive even integers. For example, 2, 4, 6, 8, 10. That's 5 consecutive even integers. Consecutive being a key word, meaning one after another. Even, another key word, meaning obviously even integers. Now, we're told that m is the fourth value, or the fourth integer. So go ahead and put an m right here. Because take a look, isn't 8 the fourth integer in that set from 2 to 10? So in this case, m would take the place of 8. Well, next, ask yourself, how do you get from the 8 to the 10? Well, you add 2. So the next term is just going to be m plus 2. Okay, that's easy enough. And now we have to work backwards. Working backwards, what we're going to notice is, if we take the 8 and want to go to the 6, we need to subtract 2 from m. So we'll call this m minus 2. Then to get to 4, we're going to have to subtract the 4 from m minus 4. To get to 2, m minus 6. And now we have our 5 consecutive even integers with m as the fourth integer. The problem does not ask us to stop there. The problem asks for the sum move on to example 5. Example 5 is a good one. This is a physics problem, really. And if you think you're good at these or you enjoy these kinds of problems, I would highly recommend considering engineering or physics as a degree when you move on to college. So this problem says, a train leaves town traveling at 50 kilometers per hour east. 3 hours later, another train leaves town traveling 75 miles an hour east on the same road, or the same track in a sense, in the same direction. How long will it take the second train to catch up to the first? So here's what I'm thinking right now. I got it. My first train, it leaves at a certain time. And the second train leaves a little bit after. How much later after? 3 hours later. So that's what's going on in my mind. They're both going east. We consider east to be to the right. So I'm drawing my rays to the right. Now, for this kind of a problem, let's remember what we have really. We have a distance rate problem. And we know that d equals RT. Okay, d is always equal to RT. Next, think about the fact that when the first train has traveled for a certain amount of time, the second train has traveled 3 hours less than that. So for example, if 8 hours went by and the first train traveled for 8 hours, the second train would have only traveled for 5 hours, because 8 minus 3 gives us 5. So what we can say here is that we can separate this into 2 different instances. We can say that the first train travels a certain distance at a rate of 50 kilometers per hour after a given amount of time. But the second train, when it travels another certain distance at a rate of 75 kilometers per hour, has only been traveling for the same time minus 3 hours. Again, the first train, and think about it logically, use numbers. If the first train traveled 10 hours, the second train would travel 7 hours, or 3 less. So that's where our 2 equations come from here. Now, the problem says, how long will it take for the second train to catch up to the first? So we want to know, when will the time be that they've traveled the same distance? Therefore, these 2 values of d, which we could really denote as d1 and d2, are the same. So if those are the same, and they're equal to their other quantities by the transitive property here, we know that these quantities must also be the same. So we can go ahead and set them equal. So we've got 50 t equals 75 parentheses t minus 3. Okay? Again, 50t equals 75 parentheses t minus 3. Let's extend this page. So, we can now solve this problem algebraically. This is quite simple. We're going to get those numbers. Again, remember, you must distribute. You must distribute. At this point in time, doesn't matter what we do, solve it any way you like. Subtract 75t, subtract 75t. We're going to get a negative, but it doesn't really matter again. So we got negative 25t equals negative 225. Divide both sides by negative 25. Okay, negative 225 over negative 25 is 9. So we get t equals 9. Remember, what are our units? We go back, look at the original problem to check out our units. Well, in this kind of a problem here, we're talking about time, and time was given in hours. Hours. How do I know that? I simply know that because my rate was given in kilometers per hour. Kilometers per hour. Again, see this kilometers per hour here indicates that my unit of time will be, it will be hours. It will be hours. So let's go ahead and put the units of hours. So, how do I write this as a statement? As a statement, you would write, after 9 hours, train 2 will catch up to, and then it's going to actually overcome it, the first train. And remember that. Train 2 is traveling at 75 kilometers per hour. So once it catches up after 9 hours, they're at the same point. And now it's traveling faster, so it's not only going to catch up, but it's going to then go beyond or overcome the first train. All right, let's look at example 6. Example 6. You decide to go for a jog from your house, and you run, you run south on Park Avenue at a rate of 8 miles per hour. An hour later, your brother also left home to go for a jog, but ran north on Park Avenue at a rate of 6 miles per hour. So right away, draw a boundary. Before we get to the answer, let's go ahead and put your house right here. You're running north. You're running south. Let's put your vector as red. You're running south at a rate of 8 miles per hour. Your brother then decides to run north at a rate of 6 miles per hour. Remember, there's a time lag here. There's a 1 hour time lag between when you both start. So you get like a head start going south. Now, the question says, how far apart were you two after W hours have gone by since you left home? Okay. So, let's think about this problem similarly to the last one. For you, W hours have gone by. But for your brother, it's been W hours minus 1 because he started an hour later. So for example, if 10 hours went by, for your brother, only 9 hours went by. So in this sense, you're running in opposite directions. And think about it. As you spread further and further apart in opposite directions, your distance increases as the sum of your two distances. So let's think about this. For you, distance equals rate times time. The distance you've traveled is your rate, which is 8 miles per hour, times the time that's gone by, which is W hours. Notice my units match up. 8 miles per hour, W hours. So my distance in the end will be miles. Again, it will be miles. And how do I check that? 8 miles per hour times W hours. Take a look at your units, dimensions, analysis. Cancel your hours, you're left with miles. So your distance traveled is going to be 8W miles. 8W, and the units are miles. Next, your brother. Your brother is also using D equals RT as a formula. He travels a distance D, but his rate is only 6 miles per hour. Now, the other thing we have to consider is that W hours have not passed for him. Really, W minus 1 hours have passed for him because he started an hour later. So we put W minus 1. Okay? So, if one person traveled a certain distance this far, another person traveled a certain distance this far, the distance apart is the sum of these two distances. And if you remember, when you think back to middle school, when you learned basic geometry lessons, you learned about segment addition postulate. The sum of these two segments equals the whole. So the distance traveled here plus the distance traveled here will equal the entire distance. So we take these two distances and we sum them together. So the sum of the distances will equal however far we've traveled. Remember, this big symbol is called sigma. It means summation, or add everything together. So the sum of the distances, how many distances do we have? We have 2. So we can see the sum of the distances, where di means however many distances you have, and we start with 1 and go up to 2. Well, that really just means add d1, which is right here. d1 is here, and d2 is here. Okay? So we're going to add these two expressions together. Let me extend this page so we have more room. Now, when we sum them together, we have 8W plus 6 parentheses W minus 1 in brackets. But remember, for this problem, not remember, but let's put these in simplest terms so we can see what's really going on here. So we'll distribute the 6. We're going to get 6W here, negative 6. Thus, our answer will be 14W minus 6 units of miles. Now, before we go on to the next example, let's make sense of this answer. First, notice you have a 14. And if you think about it, 14 is the sum of your rates. One rate was 6, one rate was 8. So really what's happening is, if you go in opposite directions, the rates are really combined because you're moving apart. But where does that -6 come in? Well, this -6 just simply means your brother missed the first mile. And since he was running at a rate of 6 miles an hour, he missed running on the first 6 miles. So you have to take away that first mile because he didn't really accomplish that first hour like you did. So you take a rate of 14 miles an hour really, but you get rid of the first mile or the first 6 miles or the first hour that your brother did not take part in. Okay, let's move on to the last example. The Mathematics Club at Loyola has 26 members. The number of boys is 4 less than twice the number of girls. How many students of each gender does the club have? Okay, now first solution. You've heard of these things before called let statements. We should use them because it does help. So, if we let G equal the number of girls, G for girls, then we can say the number of boys is going to be 4 less than twice the number of girls. So 4 less than twice the number of girls. That will be the number of boys. Again, we did this with example 1, but we're going to continue. Example 1 where we came up with these expressions. So, how many students of each gender does the club have? Well, we know that there's a total of 26. So, if we sum together the number of girls plus the number of boys, it's going to equal 26. So let's go ahead and do that. We'll take our 2 expressions that we have here and we'll sum them up. So we're going to have G as our first expression plus the number of boys right here. But the number of boys is this expression in terms of G. And now we have one variable and only one equation, so we can sum. We're going to have 3G minus 4 equals 26. We're going to add 4 to both sides to get 3G equals 30. Therefore, the number of girls is 10. Don't forget, though, this problem said how many of each gender. So we can do one of 2 things. We can use logic and say, well, there's a total of 26. There's 10 girls. Therefore, there's 16 boys. Or we can take this 10 and plug it back in up here. Take the 10, plug it in for your value of G. 2 times 10 is 20, minus 4 still gives us 16. So either way, the number of girls is 10, the number of boys is 16. Okay, so you're to watch this video this weekend. You've probably just finished watching the video, obviously. And then what I'd like you to do, start taking a look at some of these problems. Okay, you have already this weekend section 1.7 to do. You're going to do 1.7 for your homework. You're going to do 1.7, this is section 1 I'm talking to you right now. You're going to be doing 1.7 for your homework and working on your problem set. Look at 1.8. You don't have to do them all, just browse through them. And when you get back to school, we don't have class on Monday. On Tuesday, we're going to work on these problems together in class to see how we do on them. Then we'll work on section 1.9 on Wednesday, which will bring us to our last section before our test. On Thursday, we'll begin section 2.1, and we won't have that on the test. But on Friday, the test will be all of chapter 1. If you're in section 2, you're watching this video, and it's currently Monday night. So on Monday night, you're doing the same thing. On Monday night, you should have hopefully finished your problem set over the weekend, but on Monday night, you're to be working on section 1.7 homework and to be watching this video. And then when you get back into class on Tuesday, we're going to be back parallel with section 1, and you're going to, again, be working on the same section. We're going to be working on section 1.8 on Tuesday in class for both. Okay, have a great weekend, everybody.